Now let's take some time learning about what it would look like when you get one real solution, okay? Again, we're looking for a solution, we're looking for our zeros or where our graph is going to hit the x-axis, and it's going to only happen once this time. You might not know that in advance. The question will ask you to graph it, and you'll have to look at where it hits that x-axis. It could hit twice, which we just watched, one, or it could not happen at all. So, looking here, this is clearly not in standard notation. However, it still has an x squared, so we know that our result's going to be a parabola graph, or it's a equation that we can solve. So, first steps first, just like before, we're going to change this to standard form. Okay? I'm going to shift everything on this side over here. That is the normal tendency. The things on the left get moved to the right. Okay? So, to move this, I'm going to subtract 14. I'm also going to add x squared onto this side. So when I do that, my result is going to be a 0 over here. I'm going to have a positive x squared. I'm just going to try to arrange it in this as I'm going across. Next, I'm not having any x's at all, so I can keep my minus 6x. And then I have a plus 23 and a minus 14. So I would do 23 minus 14. My result is going to be 9. So I will have a positive 9. Now, this is clearly something we can do something with. Initially, this, you're like, I don't necessarily know what A or B is, and really, if we look, our A changed. Again, the normal thing to do when you come across a situation like this is to isolate a 0 on this side of your equal sign. So, we'll get rid of that nasty looking one. Okay. You will see ones like that. Okay, they are not all going to be put in this form for you initially. You're going to need to do some rearranging. So, looking at this, next step to graph it. Graphing it, we find our vertex first. Negative b, 6, over 2a, 2. 6 divided by 2 is 3. So that means that the x value of our intercept is going to be 3. Excuse me, not intercept. I meant to say our vertex. Now we're going to plug that 3 into our equation. We'll have 9 minus 18 plus 9. So 9 minus 18 is negative 9. Plus 9 equals 0. So that means our y value here is going to be 0. So our vertex is going to be over 3, 1, 2, 3, up 0, right there. Normally, if we're going to continue graphing this, we'd find our y-intercept, which we know is our c value, 9. So it's going to hit 1, 2, 3, 4, 5, 6, 7, 8, 9. We would reflect it over our axis here. So it's 1, 2, 3 away. So 1, 2, 3. It would be here. And we would graph. Now with the situation we just had when there was 2 intercepts, it was obvious from our graph there was 2 intercepts. We needed to do more work. However, if you graph it and it only hits once and it's at the vertex, and when there's one solution, it is always the vertex. Whether it's the maximum or minimum, doesn't matter. If it hits once and only once, it is always the vertex. If you get to this point, you're done. So your answer is x, such that x equals 1, 2, 3. Okay? So your solution, just one number, where x is 3. The last situation we're going to look at is when there are no real solutions. No zeros, and it never hits the x-axis. The graph still exists, but it's never going to hit this line. Okay? So this is a situation where we're going to see this. We'd see this equation either set equal to 0 or set equal to y. So, like always, we're asked to graph it initially in this section. We're going to learn how to do it algebraically later, but I want you to see where it comes from right now. We're going to be asked to graph this. So we're going to start out with our vertex, negative b, which is 15, over 2 times negative 1. So we end up with negative 15 divided by negative 2, which is a positive 7.5. I know it's a decimal. I know they're not your favorite, okay? But it's reasonable that we could get that at some point. So the first coordinate is 7.5. Now this is going to require a little bit more work, okay, to go through and solve this. So I'm going to plug in my 7.5 Remembering that this negative here is transferred, but it's outside the parentheses, so it is not part of what is being squared. So negative 7.5 squared plus 15 times 7.5 minus 63. Now I'm going to start going through simplifying this. I got to grab a calculator. All right, so we're going to start off by doing 7.5 squared. So 7.5 times 7.5. And the product is 56.25. I'm going to bring down my negative sign. Now I'm going to add to it 15 times 7.5. 15 times 7.5, 112.5 minus 63. So I'm going to start off doing this. I'm going to subtract this piece and this piece from it. So I'm going to clear it out. 112.5 minus 56.25 minus 63. My result is a negative 6.75. Again, it's a decimal, and that's okay. We can graph this point still. Negative 6.75. That's my y value. So I'm going to take a second and graph it. I'm going to go over 7.5. 1, 2, 3, 4, 5, 6, 7, 8. So 7.5 will be here. And then I'm going to go down 6.5. So negative 1, 2, 3, 4, 5, 6, 7. 7.5 will say is like right about there. So I'll follow that over. Follow this down. Here approximately is my point. Now, normally we do our y-intercept. We look up here, holy cow, negative 63. That's going to be crazy down here, okay? But we actually don't have to graph it. We just need to use some logic here, some reasoning. We need to think about it. If our y-intercept, will say, is even down here, you can't see that point. Yeah, you can, okay? Right here. This graph, the other one will be on the other side, okay? This graph is going to go down like this. It doesn't matter if it's steep. It doesn't matter if it's really narrow going down like this, okay? Either way, this graph is going down. We know that because our A is negative, saying that it's going to be a N, not a U. If this is an N and our vertex is here below the x-axis and it's a negative graph, then this will never hit this x-axis. And that's how, in this situation, from a graph, and from this equation, we can see we're going to get no solution. The graph exists. It's a N upside down, centered right here at this coordinate pair. But it will never hit the x-axis, so essentially there is no solution or no zeros in this problem. You can come across these, and there's not a real easy way to figure out what yours is going to be without knowing a little bit about what the graph looks like and the algebra that we're going to spend some time learning next week. So if you flip to the back side of your notes right now, because that's where we should be, you're going to see there's a section called estimating solutions. That's a little bit trickier, so I want to go over that with you in class. However, with the knowledge that we just gained, we should be able to do easily the practice section at the bottom. Okay? So in the first part, I'll just go over the directions so there's no confusion. In the first part of this, we're given 3 graphs, and they say, from the graph, tell me the solution. Again, the solution is where it hits the x-axis. So, write down what those x values are. Below, these two require a bit more work, so at least try to do one of them on your own. Here, it says find the solution to each equation by graphing. That's what we were looking at. You're either going to get 2 solutions, 1 solution, or no solution. Okay? Either way, all of them are going to give you a parabola as a graph. So, to graph, vertex, y-intercept, they should fit on these grids I gave you. There should be no problem with that. Okay? Once you do that, you should be able to tell me what the roots are. Remember, roots are zeros. Zeros are solutions. They're the x-intercepts. So this should be able for you to be done. They're all going to be nice numbers. There's going to be no decimals in them. It's not going to be like the last one we did. Okay? So take your time. Do your best. I want to see some really good effort here. Okay? Thank you for watching my video.